Right. Time for us to start getting this together. Where did my lesson go? I need to start recording data. So I'm going to move around the room. I want to know your Chips Ahoy. And then I'm going to come around and ask for your Kroger, because we used Kroger, not Meijer. All right. So I'm just going to kind of move down the rows. Chips Ahoy. How much? 21. B. Kroger. Or not Kroger, Chips Ahoy. 24. Maya. 19. 18. 21. Did you count your chips? 12. 18. 18. 21. All right. So we need to find the average. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And is 17 today? All right, so I need somebody working on the average number of chips in a Chips Ahoy. I'm going to come around and also ask for your Kroger brand. I'm going to write that down right here. So I'm going to start with Anthony.
15. 18.
Maya, what was your Kroger brand? 20. Lacey, Kroger brand? 13. Ooh, you got a lot of chips in yours. 13. 25. Morgan? How many? 22. 14. And Logan? 17. All right. I need averages for both of those. You said 19.059. Guys, I need you to double check that. I need at least 2 other people to verify that that is the average for our Chips Ahoy. You got 19.12?
You probably need to get
19.12? All right. 19.12 then. And then we also need the average for the Chipsters. Or sorry, they weren't Chipsters. They were, what were they called? Chipmates. Chipmates.
I like that.
You said 18.53? I need somebody to verify that for me. That's the average. You add them all and divide.
Yeah.
Because there's 17 people here, so there's 17 reported numbers. I need somebody to verify for me on the Kroger Chipmates.
I also got
19.29 for the Chipmates. 19.29. All right. Please tell me if you guys get something different. So far we have 19.12 and 19.29. Do we have a difference between these two? Yes, if I do Chips Ahoy minus the Chipmates, 0.10. Positive or negative 0.10? Negative 0.10. Negative 0.10.
Oh, 17.
17, thank you. I'm going off what you guys tell me. Negative 0.17. There we go. So far, so good? Just triple checking. All right. Cool, let's talk about this now. Let me get it up here. How are we going to find the deviation? How are we going to find the sample standard deviation? There's a fast way and a slow way. You can't. We could use an equation where we would take the mean, you would do the value minus the mean, close your parentheses, square it, value minus the mean, close parentheses, square it, value plus the mean, close your parentheses, square it, add all those up. We can do lists in a calculator. So I'm going to put those values back up. You need to do one variable stats for the Chips Ahoy, and then you need to do one variable stats for the Chipmates. You could do L1 for one of them. You could do L2 for the other one. Then you would run one variable stats on list 1 to answer the first question, and run one variable stats on list 2 to find the sample standard deviation on the second one.
I deleted my list too. How do I get it back? I deleted the whole row.
You deleted the whole thing. We're going to reset your calculator. That's the easiest way to get it back. If you have a list.
All those numbers in.
Yep. You can get list 2 back?
Yeah.
When we've got all the other lists here?
I've done it before.
You want to try it? Okay, because you could always put it into list 3 also.
Wait, clear. And I hit the.
You already put all the stuff in?
No, I meant to hit clear to like add numbers and I hit the.
So that means I can just gone.
Yeah, like I just have list 1, list 3.
I didn't know that was possible to do.
Me neither.
I'm gonna try it now. And then on the other side we do the cookie, right?
Yeah.
Ooh, how did I get 118? That's not right.
Oh, no, I didn't do it.
Sarah, it's just no, but like forget all that showfire stuff. Like stuff was happening cheer.
Oh,
She
yeah.
already know a little bit, but then there was stuff happening outside of Germany. It's so loud.
No, it was just fighting with the plates. There are no.
They literally fought in the next day to work. I'm like, you guys do it. They was in no time at all.
They only had to get a little win.
They had a whole bit of it. Just because they got me there.
How do you do your one variable stats?
Stats, calc.
Yep. Stat, calc, one variable stat. Make sure that it just has list 1. You don't want anything in a frequency list. All right, so I got for SX 2.997, so we'll call that 3.
Wait, but if you put both of them at the same time, it's not gonna compute both.
If you're doing one variable stats, you need one list only. Otherwise, it's going to use the second list as the frequency count, and you don't want it to do the frequency count. No, you need one list for the Chips Ahoy, one list for the Kroger brand.
But do it individually. Like don't do list 1 and list 2 at the same time. Like how do you do it?
How do you get to one variable stat?
Stat, calc,
Yeah.
one variable stat.
Oh,
So I got 2.998. All right, and for the other one, does anybody have a value for that one? 4.59. Since I took the other one out 3 places, I'm going to take this one out 3 places. There we go. All right. If we repeated this process over and over and over and over and over, and we created a dot plot of our differences, what would it look like? What do you think the shape would look like? Approximately normal. Where do you think the center would be? It's going to be in the difference of the means. So mu x bar 1 minus mu x bar 2. It's going to be the same thing as mu 1 minus mu 2. Mu 2. Get some Pokemon in there. How would we find the spread? How would we find the standard deviation? Because we just found our standard deviations for these two. That's what the S1 and the S2 is. So technically speaking, we should do sigma of x bar 1 minus sigma of x bar 2. That would be the square root of sigma 1 squared over n1 plus sigma 2 squared over n2, but we don't know sigma. Because that is the population standard deviation. Since we don't know that, we're going to use the standard error instead. So standard error of x bar 1 minus x bar 2. And I just realized I wrote this wrong. That should have only had 1 sigma there, not 2. I apologize, guys. So pretty much exactly like the one above it, except instead of sigma, we have to use S1 squared over N1 plus S2 squared over N2.
So basically, aren't they like interchangeable? And like, if you don't have the standard, you use the other one, and the other way around.
We're going to use one for the other, but because we're having to use the sample standard deviation instead of the population standard deviation, that's why we have to use a t-distribution, because it has more variability in it. Because we're already estimating for the means, now we're also estimating for the standard deviation. Have we met our conditions for constructing a confidence interval? What are the conditions? We have to have random. I heard normality. What's the other one? Independence. And how do we check for independence? 10%. Do we get randomness? Yes. How many random samples did we have? 2, right? 1 for Chips Ahoy and 1 for the Kroger brand. Independent random samples. Make sure you have the S on there. Do we get normality? Tell me why. It said it. I'll come right back to this page, but right here, it says the population distribution of number of chips are approximately normal. Population, distribution, are approximately normal. You got to check both of them, but here it gave us both of them. And then do we have to check for independence? Do we have to check our 10% for independence? Yes. How would we check that? What'd you say? 10% condition. So how many Chips Ahoy cookies did we sample total? 17. So 17 is less than or equal to 10% of all Chips Ahoy cookies. Do you think there's at least 170 Chips Ahoy cookies?
I would think so.
There we go. And how many of the Kroger cookies did we sample? Also 17. 17 is less than or equal to 0.10 of all Kroger Chipmate cookies. At least 170 Chipmates. Yeah, that's pretty safe. So yes, we've met our conditions. Let's construct a 95% confidence interval for the true difference in the mean number of chocolate chips in Chips Ahoy and Kroger Chipmates. Oh my goodness. So what do we need to do here in step 5? If we're constructing this confidence interval, what's it going to look like? What'd you say? I still can't hear you. State plan do conclude. So we've already done most of the plan step up in number 4, right? Because what do we do in plan? We check our conditions. We've checked our conditions here. So let's just do the do step here. We'll talk about the state step and the plan here, and just like we did most of the plan, we just haven't named the test that we're using. I'll give you the name here in just a moment. How do we find a confidence interval? Close. Other way around. Point estimate plus or minus margin of error. What was our point estimate? Negative 0.17. Because we do x bar 1 minus x bar 2. So negative 0.17. Plus or minus margin of error, we need a t star. What alpha level should we use? 95%, sorry, not alpha level, confidence level. 95%. And degrees of freedom would be what? 16 and minus 1. So 16 degrees of freedom. So what is our T star at a 95% confidence level with 16 degrees of freedom? 2.12. Double check. I don't disbelieve you, but I don't have this written down for myself. 95%. 16 degrees. Yep, 2.12. Not that, again, not that I didn't believe you. What about the rest of this? Like, because that's just my T star. What do we multiply the T star by? How do we find our standard error? But remember, we have two populations here. So we have to do the square root, because we can add our variances, but we cannot add standard deviations. So S1 squared over N1 plus S2 squared over N2. What was S1 again? 2.998 squared over, what was N1? Over 17 plus, what was the other S value, the one for the chipmates? 4 point, I'm sorry, one more time. 593. Close it and square it over N2, which was also 17. So let's calculate that guy. Square root of I'm curious what we're getting here. $1.33 for that part, yes. All right, so let me swing my work around here. So now I have to take that 1.33 times my T star, 2.12. So I have negative 0.17 plus or minus 2.8196. So now we have to minus that and plus it. So negative 0.17 minus 2.8196. I got negative 2.9896. And then I add it, get 2.6496. There's my confidence interval. Do we have convincing evidence that there is a difference in the average number of chocolate chips in a Chips Ahoy and in a Kroger Chipmate cookie? Why not? Yes. So no. The interval contains positive and negative values. So 0 is a plausible value for the true mean difference. Difference in means, sorry. Difference in means, not mean difference. For Chips Ahoy, and Kroger Chipmates. If they'd both been negative numbers, what would we conclude? Would there be convincing evidence of a difference? Yes. Which one would we believe has more if they came out to both be negative? Kroger Chipmates. Because that would mean Chips Ahoy minus Chipmates. There would have to be less in the Chips Ahoy. What about if they'd both come out to be positive? More in the Chips Ahoy than in the Chipmates. But because my interval contains 0, they could be exactly the same. I don't know for a fact that they're exactly the same, but it is a plausible value. So they could have no difference, a difference of 0 between these two. All right, name of the test that we just did. Last week, we did a 1-sample t interval for mu. What do you think we're going to call this one? 2-sample t interval for mu1 minus mu2. Remember, we do intervals, we do tests for the parameter. So not x bar, we know x bar. X bar is what we found when you guys went through your cookies and counted the chocolate chips. Those are the x bar values. Yep, so we're doing it with means instead of proportions, yes. So we still have to meet our conditions. Random, 10% for independence. And then normal, large counts, large sample, however you want to phrase that one. What are the 3 ways that we have of checking off that third condition, checking off that normality? Central limit theorem. How many do we have to have for central limit theorem? At least 30. That's why we couldn't use that today. Draw a dot plot of your actual sample data. In this case, how many dot plots would we need to draw? 2, 1 for each population. As long as it doesn't show any strong skews or outliers, we're good. Or the third way that we actually used here, which was what? They told us that the population was approximately normal for both of those populations. If we know that about the populations, we don't have to check anything here. If we don't know about the populations and we don't get our central limit theorem, that's when we have to draw a dot plot. 4-step process, parameter and confidence level in your state step. Plan 2-sample t interval for mu1 minus mu2 and check your conditions. Do general formula, specific formula, numbers, answer. If you do not write down the specific formula, you just plug the numbers in and find it, that is okay. Just make sure that you know where you're going on your formula sheet for the pieces that you need to plug into those different formulas. And then conclude, we are 95% confident that, what would we say on ours? the true difference in means of chocolate chips between Chips Ahoy and Kroger Chipmates. Very nice work. I want you guys to spend about 6 minutes, 5-6 minutes, doing the check your understanding. This is all 4 steps. State plan, do, conclude. We're gonna do about 5 minutes. Like I said, 5-6 minutes here. I know some people are still working on this. Most of us are still working on this, but I kind of want to start debriefing as we go through it together. So whenever I get to the spot where you left off, just pick up from there. In the state step, what things do I need to do? Say what mu1 and mu2 are and my difference. And then what else do I have to do? State the confidence level. Remember, it's the confidence level, not the confidence interval. The interval is what we find later. What confidence level do you guys want to use? 95%. It asks us to do 95%. And then we need to do mu1 minus mu2, the true difference in the mean amount of time in minutes people spend reading. And then you have to state your direction. I did 15 to 19 minus 75 plus. So I have mu1 being my younger people and mu2 being my older people. Plan, we got to do two things. What's the two things we do in the plan step? Name and check conditions. What is the name of this test? Absolutely correct. Two sample t interval for mu1 minus mu2. Do we get random? Yes. Independent random samples. It says based on random samples of 975 and 1050. So we have independent random samples. If I'd had enough room here, I would have actually quoted that little bit. Random samples of 975 and 1050. That's so we can generalize to both of our populations. Do we get 10%? Yes, there is at least 9,750 15 to 19-year-olds and at least 10,050 75 plus. Yeah, I would probably say in America there. If you just had all people, I think in the context of this problem that would be okay, but I would probably say in the US or American. This is so sampling without replacement is okay. Do we get normality? Yes, using what? Central limit theorem. Both of them are bigger than 30. All right, so then we do x bar 1 minus x bar 2 times t star. How in the world are we going to do a t star for these two? I've got 975 and 1050. It's not the same amount. I need my degrees of freedom. Use the smaller population and minus 1. Do the smaller group because that's the more variable one. Remember, as we get closer and closer to infinity, it becomes more and more normal. So I want to account for the largest amount of variability possible here. So the smaller population minus 1. So based on the paper that we have, I can only use degrees of freedom 100 because it goes to 100 and then it has infinity. So I got an interval of negative 38.2 to negative 33.8. So we would be 95% confident that the interval of negative 38.2 to negative 33.8 minutes captures the true difference in mean amounts of time that people ages 15 to 19 and people ages 75 plus read per day. I should have my direction on there again. You have to have the direction in here somewhere. Please make sure that you come to class tomorrow with your homework. We're going to check and grade that tomorrow. One other thing briefly. If you don't have n and you're trying to find degrees of freedom, you can't do it. So if you don't have n but you still need a t star, we're going to use z star instead. If you don't know n, you have to use z star. Yes, I am.